The foremost nitty-gritty infrared transmission range of an exoplanet has stunned the complete space industry. The James Webb Space Telescope's startling revelation has brought to light subtle elements that analysts essentially hadn't anticipated. With the foremost precise investigation of a planet exterior, our sun-oriented framework, the unused telescope has once more demonstrated that a unused period of space investigation has started. What did the James Webb Telescope discover around the exoplanet WASP 96b that astounded researchers so much? And can there be life on this distant planet? WASP 96b may be a secretive drifter that has been stowing away within the unending haziness of the universe. From time to time, this exoplanet passes by like a phoenix, sometime recently its star, and after that comes the minute when we will see and consider this far-off world from soil. The interesting planet circles its star extremely quickly and at a breathtakingly near remove, turning its climate into an inferno of over 725 dejek. The gas mammoth, as it were, needs 3.5 soil days to total one circle around the star, WASP 96. Since its disclosure in 2014, the primary planet found in this star framework has postured astounds, and presently researchers have set almost unraveling these secrets with the new James Webb Telescope. WASP 96b is found alongside its star approximately 1150 light, a long time absent within the constellation of Phoenix, and it is most likely a gas giant. WASP 96b is, as it were, around half the estimate of Jupiter and most likely features a sodium-rich air. Indeed, in spite of the fact that it is to some degree comparable to the biggest planet in our sun-based framework, WASP 96b could be a world that has no direct partner in our framework. In June 2022, the Webb Space Telescope captured the cleanest signature of this secretive far-off world, and people on soil are intrigued. Webb demonstrated its exceptional capacity to absolutely analyze the climates of far-off planets for the primary time. Here, the researchers found water and proof of clouds and cloudiness in the air of this hot, bloated gas mammoth planet WASP 96b. What precisely do we know? This chart got researchers all excited. James Webb struck with his near-infrared imager and slitless spectrograph and uncovered the barometrical properties of the hot gas monster, WASP 96b, so absolutely that it cleared out stargazers puzzled. It's a bit like looking into a removed house with binoculars and abruptly being able to see all the details. You'd be flabbergasted and probably just as energized as the researchers who looked at WASP 96b in 2022. It's nearly as on the off chance that we were right there, presently seeing the planet with our claim eyes. Cosmologists enthused almost this masterpiece, and what was already simple guess all of a sudden got to be unmistakable fact. With his NIRIS instrument, James Webb delivered a total transmission spectrum, the most exact we had ever had of an exoplanet. The transmission range is delivered when starlight sifted through the planet's environment is compared with unfiltered starlight. This sort of perception is only possible if the planet circles following to or in front of its star. Researchers call this passing of the planet a transit or transmission. The foremost accurate data is gotten with this type of perception when the planet is following to the star. James Webb makes a chart from 141 individual information focuses. Within the graph, these can be seen as white circles, and each of these circles speaks to a particular wavelength of light. The contrasts are caused by the assimilation of starlight by the planet. A few light waves are moreover blocked or changed by the planets, making a light engrave of the coordinate planetary environment. As the surfaces of the planets reflect light, conclusions can be drawn from the diagrams about the surface properties of the planets. One of the light bands from Webb's near-infrared imager and slitless spectrograph appears the change within the brightness of the light as the planet passes the star. Inside the chart, The wavelengths run from 6 micrometers, appeared in red, to 2.8 micrometers, which is as of now within the near-infrared range. This unused innovation is phenomenal, and for the primary time in human history, it is conceivable to form exact explanations around distant exoplanets. Analysts are now able to detect the wealth of important gases in a planet's climate within the assimilation designs of light. Each gas has its own typical light wave pattern, and Webb actually recognizes these structures completely naturally, conveying the wrapped-up graphs and estimation information after some hours of observation. Researchers can study a fantastically wide range of data from the statures of the transmission information crests, permitting translations of the temperatures within the environment. And, of course, we get information on imperative gases or angles, such as water. A more smoking planet like WASP 96b appears strikingly tall crests within the bends, and exceptionally particular designs uncover water vapor and clouds. The parameters within the measurement diagrams are variable, and it is even possible to create forecasts, approximately the thickness and stature of the cloud cover. Other charts reveal the wealth of different gases and appear biomarkers. It'll take a long time to fully analyze the information on WASP 96b, but researchers were able to share the 4 most exciting facts about this world with the open quite quickly. For example, we presently know that there's water vapor in this world. Crests within the transmission curves show the presence of clouds, and a slow diminish within the range indicates a conceivable cloudiness. The tall barometrical temperature of around 725 Dejek was moreover determined by estimation bends like these. There is nearly certainly no life on WASP 96b. In the event that it were a gas monster, it would likely be fair as inhospitable a world as Jupiter or Saturn. This nitty-gritty infrared transmission range truly does resemble a supernatural occurrence, and however, there's solid technology behind it. The reality that Webb would be able to analyze far-off universes was aiming, but the greatness with which this telescope presently performs its work never ceases to astound the logical community. We have, as it were, been able to identify exoplanets in the vastness of space since the mid-1990s, and presently, for the first time, we can learn pivotal, subtle elements, almost these removed universes. WASP 96b may not be a promising candidate for life as a gas giant, but the rebellious of the James Webb Telescope are able of identifying Earth-like planets and prove of life. The exact observation of WASP 96b was carried out utilizing the SOS mode of NIRISes. SOS stands for Single Protest Slitless Spectroscopy, and this innovative strategy analyzes the spectra of individual celestial objects without the utilize of a slit. This slitless approach empowers a broader scope of the light spectrum, which simplifies the examination and improves the quality of the collected data. The SOS module captures the spectrum over a wide run of wavelengths, regularly from 6 micrometers in the visible ruddy and up to 2.8 micrometers within the near-infrared. This capacity to capture a broad spectrum in a single introduction is particularly profitable for analyzing the climatic composition of exoplanets. It permits researchers to distinguish the signatures of water vapor, carbon dioxide, and other key particles. The James Webb Space Telescope marks with advances that go far beyond the capabilities of its predecessors. The amazing instrumentation uses infrared spectroscopy for the primary time, making it distant, more capable than Hubble or ground-based telescopes. The inventive technology and the ability to minimize interfering radiation essentially progress the direct perception of bigger exoplanets. The near-infrared camera framework, the near-infrared spectrograph, the mid-infrared instrument, and the fine guidance sensor NIR. Infrared imager and slitless spectrograph cover an exceptional range of infrared wavelengths, enabling precise examination of diverse planets and other galactic phenomena. Experts point out that we are, as it were, at the very beginning with the investigation of WASP, 96b, and the new technology, and able to look forward to seeing what completely new information on exoplanets this telescope will shock us with within the next 10, a long time. Exoplanet research on the edge of modern universes sounds difficult to envision, but of the evaluated trillions of planets in the Smooth Way alone, we have, as it were, found fair over 5,000 for certain to date. These removed universes circling stars exterior our sun-based framework are extremely difficult to watch. They transmit no light themselves, and when they pass by their stars, indeed, gas monsters are fair little specks. The Hubble Space Telescope, propelled in 1990, was one of the first instruments able of making precise observations of objects exterior our sun-based framework. In spite of the fact that it was not particularly planned for Exoplanet Investigate, Hubble has already provided us with valuable data. To advance deep in this information, researchers set the Kepler Space Telescope into space in 2009. Thanks to its capacity to distinguish tiny changes in the brightness of stars, Kepler revolutionized exoplanet inquire-about, and since its launch, the number of planets found has increased day by day. Astronomers have developed various methods to track down these tiny cosmic objects. The transit method, in which the periodic dimming of a star is observed as a planet passes in front of it, is one of the most successful techniques. Another method is the radial velocity method, which measures the movements of a star due to the gravitational influence of an orbiting planet. These movements lead to tiny but measurable changes in the spectral line of a star, indicating the presence of a planet.